Assalamualaikum warahmatullahi wabarakatuh. So today our group will present about the comparison between capacitor and battery. So our group consists of three members, which is our leader, Siti Hadirah Balqis, and our assistant leader, Nursyahira Najwa, and the third member is me, Nik Muhammad Faiz Nasrid bin Cengah.
Firstly, let's compare the capacitor and battery by viewing the aspect of theory and principle. A capacitor has two plates separated by dielectric having equal and opposite charges. When we connect a DC power supply across the capacitor, one plate is connected with positive end and become positive when potential is applied, while the other plate connected to a negative end and become negative when potential is applied. An electric field produced across the capacitor. Positive plate collect positive charge while negative plate collect negative charge. At a particular stage, capacitor's capacitance allows it to hold the maximum amount of charge, and the time span is called the charging time of the capacitor. When the battery is removed, the two plates hold positive and negative charge at certain time, and the time span is known as the discharging time of the capacitor. Thus, the capacitor acts as a source of electrical energy. And for battery, the oxidation and reduction reactions of an electrolyte with metals operate the battery. It happens when two different metals are immersed in diluted electrolyte. One electrode becomes negatively charged, called cathode, as a result of oxidation, while another electrode gets positively charged, called anode, as a result of reduction. The oxidation and reduction process depends on electron affinity of metal of electrodes. There will be a potential difference produced between these metals when two dissimilar metals immerse in electrolyte. Cathode forms the negative terminal, while anode forms the positive terminal of battery.
So I will present about the design between capacitor and battery. So I will go on the battery first. The batteries come in many different sizes. Some of the tiniest power small devices like hearing aids. Slightly larger ones go into watches and calculators. Still larger ones run flashlights, laptops, and vehicles. Some, such as those used in smartphones, are specially designed to fit into only one specific device. Others, like AAA and 9-volt batteries, can power any of a broad variety of items. Some batteries are designed to be discarded the first time they lose power. Others are rechargeable and can discharge many times. A typical battery consists of a case and three main components. Two are electrodes and the third is an electrolyte. This is a gooey paste or liquid that fills the gap between the electrodes. The battery's negative electrode is called the anode. Meanwhile, the battery's positive electrode is called the cathode. The anode and cathode are usually made of different materials. Typically, the cathode contains a material that gives up electrons very easily, such as lithium. Graphite, a form of carbon, holds onto electrons very strongly. This makes it a good material for a cathode. Why? Because the bigger the difference in the electron gripping behavior between a battery's anode and cathode, the more energy a battery can hold. Next, the design of the capacitor. So the capacitor have a pretty basic design. The simplest ones are made from two components that can conduct electricity, which we call the conductors. A gap that doesn't conduct electricity usually separates these conductors. When connected to a leaf circuit, electrons flow in and out of the capacitor. Those electrons which have a negative charge are stored on one of the capacitor's conductors. Electrons won't flow across the gap between them. Still, the electric charge that builds up on one side of the gap affects the charge on the other side. Yet throughout, a capacitor remains electrically neutral. In other words, the conductors on each side of the gap develop equal but opposite charges, negative or positive. In some early capacitor designs, the conductors were metal plates or disc separated by nothing but air. but those early designs couldn't hold as much energy as engineers would have liked. In later designs, they began to add non-conducting materials in the gap between the conducting plates. Early examples of those materials included glass or paper. Sometimes a mineral known as mica was used. Today, designers may choose ceramics or plastic as their non-conductors.
Now, we move to technology development for capacitor. So, capacitor has started in 1960. GF Mansbridge invented the metallized paper capacitor. Furthermore, in 1920s, silver mica capacitors were developed. Cornell Dubilier Company introduced the aluminum electrolytic capacitors. Also, Bell Laboratories has made the first solid electrolyte tantalum capacitors since 1950s. The first Mylar capacitor that a very strong PET polyethylene terephthalate has developed on 1952. An American company has pioneered the multi-layer ceramic capacitor also in 1952. Capacitor is to store electrostatic energy in an electric field and where possible to supply this energy to the circuit. Capacitor can lower equivalent series resistance ESR. It is easy to get and cheap, but it is depend on types of capacitor. Capacitor has 6 different types of capacitor, which are paper capacitor, mica capacitor, aluminum electrolytic capacitor, tantalum capacitor, mylar capacitor, and ceramic capacitor. It will increase the speed at which capacitance is created. Capacitor is a passive device and works with alternating current and direct current. Next, we will discover on technology development on battery. In 1748, the term battery was first used by Benjamin Franklin. Then, William Robert Grove was invented the first fuel cell in 1839. Gaston Plant created the first practical storage lead acid battery in 1859 that could be recharged. In 1881, Tibbard invented the first battery that contained negative electrode and a porous part in a zinc cup. Carl Gessner created the first commercially viable dry cell battery also in 1881. Watmar Jungner created the first rechargeable nickel-cadmium battery in 1899. Battery can provide energy to circuit. It is a high-demand item. There are 2 types of battery, which are primary and secondary. Cell types have 4, which are AAA, AA, C, and D. It is cheap and easy to get, depends on the types of cell and the standard of the battery. Battery works with direct current only and it is a active device.
For application aspect, capacitor is used for storage of energy. It is also used in filter circuits to minimize the ripple voltage. Next, capacitors are used to run the motor, used in single-phase motor, used in high-frequency microwave system, and widely used in radio and communication. While battery is applied to power things around the house such as remote controls, torches, wall clocks, and cameras, which is using rechargeable battery. Battery is also made device in medical environment. It is used in electrocardiograms and also infusion pumps. Furthermore, battery is a power tool at firefighting and emergency response, in radio, ECG monitors, and metal detectors. Last but not least, battery is needed for military use. It is used in radio communications, night vision devices, radar communications, and optical equipment.
Last but not least, the similarities between the capacitor and battery. Firstly, both can store electrical energy that can be tapped in a closed circuit by connecting them. Another significant similarity between the capacitor and the battery is that they both have series resistance. They both can create a potential difference across other electrical components like a resistor.
So that's all from us. Thank you.